Welcome to the GSOC Geology Hour. My name is Carrie Gordon. I'm a retired Forest Service geologist.
My name is Alyssa Smith, and I'm a PhD student at Portland State.
Alex Lopez, Public Affairs Coordinator with the Oregon Department of Geology and Mineral Industries.
So I'm going to get us all started today. My segment is called Geology in a Nutshell, and my focus is summarizing some recent work for everybody in a way that is nice and digestible. So I'm going to start by talking about the recent event at Yellowstone, and then go into an article about thallium changes in the Baltic Sea. And I will talk about dating rhyolites at South Sister Volcano and iron ores from Supercontinent Breakup. So it is going to be an international day today. But first, let's start just across the way from us here, still kind of West Coast, in Yellowstone. So the event that happened on July 23rd is what the USGS is calling an underappreciated hazard in the Yellowstone region. So this is an image here of the event, and here's a little bit of what the aftermath looked like. So this here is a picture of the largest boulder that was ejected from this explosion. And this measuring tape here is 50 centimeters long. So that gives you a sense of scale on this. So the largest stuff thrown out was on the scale of a meter or a few meters. So this is an overview or an overhead view of the carnage from the event. So this occurred just before 10 a.m. and it was an explosion of hot water, mud, and rock from Black Diamond Pool in Biscuit Basin. So the Biscuit Basin, or the Black Diamond Pool is part of Biscuit Basin, is about 2 miles northwest of Old Faithful, so if that's any reference for you. And this plume of water and rock fragments is estimated about 400 to 600 feet tall, just from what they've measured from using people's pictures. All in all, there was no detected precursors to the event that were picked up by monitoring equipment. And though the boardwalk nearby was pretty heavily damaged, no people were injured. So you could see from the previous picture that there were definitely people there, but people were able to move out of the way in time. So that's good. But this basin area is closed until geologists can fully assess the activity there. So from what geologists have observed so far, the debris from the event was pretty shallow material. So the stuff thrown out was like glacial materials and siltstones, sandstones, and gravels that are all shallow material in this area. And what is how they were able to constrain that so quickly is that there was no bedrock that was included in the ejecta. So they know there's a rhyolitic bedrock about 175 feet down. So all of the material that was thrown out has to be shallower than that. That's not too surprising because most of these hydrothermal explosions are pretty shallow. So this is all good news, right? So if we consider kind of the other activity that happens in the area, and I'm going to make this front and center. So I want to show the different kinds of events that can happen at Yellowstone and how we would think about like how often should these be happening. The small hydrothermal explosions are pretty frequent, but they're not very destructive. So I know this looks like a lot to us, but on the grand scale of things, pretty small. So we could expect several to many per century. And then the more destructive these events get, the less frequent they are. So strong earthquakes would be significantly more destructive, but they're going to be less frequent. So 1 to several per century. Lava flows, bigger problem, but also less frequent. And then those big caldera forming eruptions that everybody worries about are really infrequent. So 1 to 2 per million years based on the geologic record. So kind of what I wanted to highlight with that is that just because there was this event there that maybe we personally don't see all the time, it's something that in the grand scheme of things is something that happens often at Yellowstone and doesn't necessarily mean that it's a precursor to anything bigger. We always do like to hear that. So on to the next article. So EOS does a really good job of putting out summary articles. So I pulled this one. The summary article is called Toxic Metal on the Rise in the Baltic Sea, and that was published in June of this year. And that's based off an article called Anthropogenic Forcing of the Baltic Sea Thallium Cycle that was published by Ostrander and others in May of this year. So pretty fresh news still. So what this article looked at is chemical changes in the Baltic Sea and how those are linked to human activity. So the way they measured this is by using isotopes of thallium in sediment cores to observe changes over time. So the sediment core is in there. So the change in thallium isotope signatures in sediments in the Baltic Sea, beginning between about 1940 and 1947, they found correspond to other human-related signatures that have been measured by other means. So what is thallium, though? Because that's not something we talk about often. Thallium is element number 81 on the periodic table. So this is classified as a heavy metal and it's incredibly toxic. So the article cites that thallium is the most toxic metal for mammals. So it's got a very low minimum lethal dose. And because thallium has such a low boiling point, it tends to be volatilized and released through atmospheric emissions following coal combustion, cement production, and pyrite roasting. And more thallium tends to be driven off into the atmosphere than remains in the product. And then what happens is that volatilized thallium condenses on ash particles in the atmosphere and eventually ends up in places like the ocean. Not great. But rather than measuring the concentration of thallium, the study used two isotopes of thallium. So those are two different masses of the thallium element. And the significance here is that they're produced by different processes, right? So it's much more useful than just looking at thallium concentrations because it doesn't just give you how much, but it tells you how much of these different processes might be at play. And if you go to the article, which I'll make sure to share the links with everybody, you'll see that they represent it in what's called epsilon notation. And that's just they compare the ratio of those two masses of thallium, so that they took in a study, to a standard. And the whole reason for that is that the numbers look a lot nicer. Let's go back to the ocean now. So the article talks about dead zones, which are areas in the ocean with very low dissolved oxygen. And there's many reasons for these dead zones, but essentially like warming, water, and pollution makes the water become stratified. And so it can't mix due to density differences. And so the Baltic Sea already has pretty low dissolved oxygen just because it's a pretty geographically isolated area. But the impact of human caused pollution has caused it to become the largest human-induced hypoxic area, so low oxygen area on Earth. So there have been people who have put forth some ideas on how to fix this hypoxia. And one of the things, and I just used a clip art of a pinwheel here, wind turbine here, but actually the diagrams I could find looked pretty similar. The idea is just literally pumping oxygen into the Baltic Sea. So that would solve part of the stratification. But one of the problems is, and this is why it's such a complicated issue, is that these low oxygen conditions also keep that thallium that is dissolved in the water, they keep it lower. So if they were to oxygenate the water, it might actually release more thallium. The whole thing there is, like, my summary is that the solution is going to be kind of complicated, kind of ending on a bummer. The next article is nice and close to home, also a fresh off the press article. This is about dates and storage for young rhyolites of South Sister Volcano. So the original article was posted just last week in G Cubed, or Geochemistry, Geophysics, and Geosystems by Annika Deckert, who is a current PhD candidate at University of Oregon. So her article is called Zircon Constraints on the Eruptive Sequence and Magma Evolution of Rhyolites at South Sister Volcano, Oregon. One of the significances of the South Sister is that it's one of the few areas in the Cascade Arc where true rhyolites have been erupted in recent geologic time. So rhyolites tend to erupt as these viscous lavas that form these blocky domes. And I wish you could get the scale on this picture, but this is a very, very tall. I'm really bad at estimating distances, but I'll just say that it's at least double or maybe several times more the height of a basaltic flow, something that's more common in the Cascades. And when these events happen, they tend to be pretty explosive eruptions, and they produce a lot of ash and pumice, so things that need to be considered for hazard mitigation. So the South Sister is also classified as a very high threat volcano by the USGS's system classification for volcano hazards. And it's an area where ground inflation has been monitored since the 1990s. So this is an example of the monitoring equipment that they have in place. Any sorts of new dates on these types of eruptions are really important for people who are trying to study hazards, especially because this is an area with a growing population, and a lot of people like to go there and recreate. So very important new study. So this is a wonderful map from this study that shows all of the different young rhyolites associated with the South Sister and areas where new analyses were done. So I'm not going to go over every unit here. I instead want to highlight that there have been 13 of these rhyolitic eruptions at South Sister within the last about 51,000 years. The significance of what they found in this study is that 2 of the dates that they collected, which are these samples right here, turned out to be 10,000 years younger than previous estimates. On the axes here, we have cumulative erupted volume on the y-axis and the model age in thousands of years on the x-axis. And all of these different lava types from the South Sister represented in different colors here. But I don't want to talk about all of that. I want to narrow in on the rhyolites because this is what we're focused on. So the new data collected meant a shift in the earliest dates and also a change to the erupted volumes. So the old dates are here. So look, earlier estimates closer to about 51,000 years, and the new dates push it closer to about 39,000 years. And so what this also means is that the erupted volume estimates over time changed. With these new dates considered, the average eruptive dates about doubled for the earliest phase, the cone building phase of South Sister. And even though with that in consideration, so that's significant, that's important for us to know. One of the things for us to recognize is that the eruptive rates at South Sister are still moderate compared to other Cascade volcanoes that have significant studies. Now to look in, my animations went out of order, but that's okay. That's just how things go. These 2 diagrams here contrast lavas of different ages. So the Holocene lavas, which are younger, are the reds, and the Pleistocene lavas, which are older, are the blue colors here. And what I want to highlight here, instead of going over all of these parameters, is the europium star values, which more simply said is the europium anomaly values, and the niobium values. So what they found in this study is that there's a contrast between the lavas of the different ages here. So the younger lavas, the Holocene lavas, tend to have higher niobium, and then they also have lower europium anomalies. What this means and how this is interpreted is that the melt-rich bodies that source these eruptions are physically distinct between the Holocene and Pleistocene. It's just another thing to consider when they're thinking about storage and future eruptions, is that where lavas were stored previously may not necessarily be the same place that they would be for future eruptions. It's a great paper. I recommend reading it, especially if you love chemistry as much as I do. So we are going to hop in a little plane now for several hours and cross the international date line and go to Australia. The summary title for this article is actually longer than the article title. So the summary title is World's Largest Iron Ore Deposits Formed Over 1 Billion Years Ago in Supercontinent Breakup. So that was published just earlier this month in Life Science. So the original article, like I said, shorter title, A Billion Year Shift in the Formation of Earth's Largest Ore Deposits. So that was published in July of this year. So very, very fresh research. So this image here shows the Pilbara Craton of Western Australia. And the thing here is that this is the Earth's largest and most economically significant iron deposit. So at least that have been directly dated. What they found in this study is that the deposits are up to 1 billion years younger than previously estimated. And through their research, they also determined that it's likely that this deposit formed during a time of breakup and formation of supercontinents. This is a map of the region, and I'm not going to go over this whole thing, but I know some people love a good map and strat column. So the study collected samples, which are the blue stars, specifically from the mineralized deposits. So on the map, you'll see these red colors in the strat column that show mineralization events. And so that's what these are here. And these are what the samples look like, which are really neat. So these were mineralized units sampled from hematite ore clasts from conglomerate beds. The banding that you see in some of these is relict BIF textures. So for some people, they're going to get really excited, and for others, you're going to say, what's BIF? Well, I can answer that for you. So this is an image of a BIF. I believe this one's from the upper United States, but I can't remember. But banded iron formations are these deposits that form through deposition of iron oxidized in the water column. So these are pretty significant, and almost all of these formations on Earth are of Precambrian age and are thought to record the oh my goodness, what a word, oxygenation of the Earth's oceans. So they provide a nice record of deep time between the ocean and atmosphere, as well as with the crust. Once these BIFs are deposited, they can be further transformed by a fluid-driven process called an upgrading event. And what that does is that removes silica and carbonate from the deposit and also oxidizes the iron. And then it produces iron ore, which is a really important thing in our society. And so the issue previously is that these have been pretty hard to date. But there have been recent developments in hematite geochronology using uranium and lead to provide direct dating. So this is a pretty cutting edge new thing. So I previously mentioned that these are these hematite ore clasts from conglomerates, and that what they had been able to constrain previously is that the dates were about 2.2 to 2.0 gigaannum, so 2.2 billion years ago. And they tied this to an earlier upgrading event. And what's significant there is that it gives a potential link to deposits in South Africa that are associated with the Bushveld superplume event, and so continental breakup. But they found with the spot analyses of hematite that they added in a second upgrading event at 1.1 to 1.4 gigaannum. So what that means is that the Pilbara craton actually saw two periods of iron enrichment. So that's associated with supercontinent assembly and breakup. So there was the earlier period around 2 billion years ago, and then that more recent event just over 1 billion years ago. And so the size of the deposits also reflect that this mineralizing event happened on a cratonic scale. So a very broad event. And then the last thing I'm going to say, I told Paul a little bit about this, but I've been working with the Central Oregon Geoscience Society to recruit people if you're going to be hiking around in Central Oregon. There's some areas I'm not going to be able to get to. If you like to go out and be in nature and think you might be kind of in the vicinity of the PCT, reach out to me. I'm providing coordinates, detailed instructions, all of that. I can talk more about it later, but essentially just email me if you have more information on that. But with that, I'm going to wrap up my little segment and say tune in for more Geology in a Nutshell next month. And if there's any broad topics you want to see, I'm going to source from what research is recent. But if there's like you want to hear more about landslides or more volcanoes, just let me know, because I'm definitely willing to cater to what everybody else wants to see.
All right. Thank you, Alyssa. We did have one question that showed up in the chat.
Sure.
And it went right back to Yellowstone. What was the lithology of the black diamond ejecta? Age, maybe method of deposition? I think one of your slides said something about glacial.
Yes. Okay. So yeah, it tended to be pretty shallow stuff. So a lot of more recent, I don't know the exact ages on these things, but pretty young stuff, pretty shallow. So a lot of sedimentary stuff, probably erosional processes going on there. Soft rock. I wish I knew an age on them, but younger than the rhyolite.
So, Alyssa, would you like to do the honors of introducing our second speaker for the morning?
Yes, yeah. So Alex Lopez is joining us from the Oregon Department of Geology and Mineral Industries, also known as DOGAMI. I always have to look up what the acronym is. But DOGAMI, as a lot of us are more used to calling it, and he's currently working as the public affairs coordinator there. So he also has a background in social work, and so his work focuses on the intersection of community well-being and earth sciences, and he specializes in accessible science communication, and we are very excited to have him with us today.
Thank you to Alyssa and Paul and the rest of GSOC for providing this opportunity for me to talk about a subject that I'm super interested in and that I've been interested in for many years, and that is the community dimensions of geoscience practice. All right, so I want to start off with just a little brief introduction of myself. That is me on top of Mount St. Helens many years ago, looking over the cliff. At this point, Mount St. Helens was actually in the process of erupting. I believe this was 2005, so it was really an exciting place for a geologist to be. As Alyssa mentioned, I am a geologist and a social worker. Currently, I'm in the role of the public affairs coordinator at DOGAMI. I'll talk a little bit more about that and my duties there a little later on. And I did want to mention that I've worked with Paul for actually a few years now on various different things, including the CEI Hub legislation from a couple of years ago, the NAACP Environmental Justice Subcommittee, the outreach committee for the Oregon State Board of Geologist Examiners, and then here at GSOC. Thank you, Paul, for facilitating this as well. As I mentioned before, I'm going to be talking about the ways that community interests are impacted by the practice of geology. And to get there, I'm going to start with a little bit of information about my career, because I'm finding myself occupying a relatively unique niche in the geosciences. And so I just want to explain a little bit about how I got there. So what got me interested in geology in the first place? I actually grew up in Houston, Texas, and had a family that was really interested in the sciences in general. So they encouraged my sister and I to just explore as much as we could. I had a grandmother who was incredibly enamored with rocks, particularly crystals that she would pick up on her trips, frequent trips to Mexico, and she would bring them back to me, and I would just ooh and ah over them. And finally, I have to mention that because of the petroleum industry, Houston really had a lot of educational resources related to geology and earth sciences. I have feelings about the petroleum industry that I won't talk about here, but as a kid, I was frequently exposed to geology and earth science concepts. The photo here is really interesting. This is from an exhibit at the Houston Museum of Natural Science, and shows one of their large exhibits about drilling wells. So what you see there is a very large drill bit that folks are looking at. And so as a kid, I went to that museum probably 6-7 times a year, and I was exposed to this over and over. So that really just speaks to how educational resources can impact kids and communities. So let's see. I went to college actually at the University of Texas. I started off in the math program, but the moment I took my first geology class and ended up on a field trip, I switched my major because clearly that was the preferable degree. I did end up going back and getting my math degree. So eventually I ended up with a bachelor's degree in mathematics and a bachelor's degree in geology with an emphasis on geophysics. After graduating, I worked for the University of Texas Institute for Geophysics, getting some really background experience in seismic data collection, and that put me squarely in the sights for ExxonMobil recruitment. So a couple of years later, I ended up actually working for ExxonMobil Exploration Company in Houston. I worked there for about 4.5 years, but for various reasons, that really wasn't where I wanted my career to end up. Of course, if you go to school in Texas for geology with an emphasis in geophysics, you will learn a lot about the petroleum industry. But I realized that my career interests were really elsewhere. It was at that point that I applied for and was actually recruited into a position in environmental consulting and environmental remediation here in Portland. So that was 2005 when I moved up here. Um, Environmental consulting, I came in really green, but it was a great opportunity to learn about Oregon environmental regulations, environmental science concepts, um, environmental cleanup methods, remedial engineering. And it was really the first place that I began to see the social impacts of the geoscience profession and how that really impacted communities on the ground. One of the first things I did was actually start volunteering with a local environmental justice nonprofit called the Portland Harbor Community Coalition. This nonprofit generally works on issues related to the cleanup of the Willamette River Superfund site, and it was my intention to help that organization by bringing some of my technical knowledge into their advocacy work. I will actually talk a little bit more about PHCC as I've been associated with them ever since. Um, and that experience eventually led me into social work school. So, in a nutshell, the executive director of the Portland Harbor Community Coalition is actually a social worker, and kind of opened my eyes to the role of social work and the role of communities in environmental cleanup and geoscience practice more broadly. Um, so I did briefly want to touch on what social work is because there's some confusion out there, I think, and probably some of you are wondering how that relates to geology. So as you may be familiar, social workers are professional helpers who look holistically at individuals or communities to help find resolution to issues. Social work is a little bit different from, for example, a psychologist or a psychiatrist who look very specifically at challenges, mental health challenges that folks might have. Social workers actually take those into consideration, but also try to understand other dimensions of an individual or community's experience, such as income level, racial discrimination, or other social factors. So social workers really take a holistic look at this. On the individual level, social work looks like counseling or financial coaching or potentially drug rehabilitation. But we can actually take those same concepts and blow them up to a community scale. So with respect to environmental issues, that can look like working with communities to understand what environmental impacts are being experienced by that community, looking at contaminated properties that might be within those communities, or things like helping nonprofits through technical or regulatory issues. So through my education, career experience, and volunteer work, I really began to understand the deep intersections between the practice of geology and community interest. And the social work degree and experience, I can't express enough how much it really opened my eyes to all of these different issues coming together. So after graduating from social work grad school, I began, or I continued my work with the Portland Harbor Community Coalition. As I mentioned, I started volunteering with them in about 2012. Started out as just a volunteer, ended up doing some of my social work internships there. For a short while, I was a staff member. Then after transitioning into my role at Dogami, I also ended up on the board, and now I'm the board chair of the Portland Harbor Community Coalition. So I still maintain my ties with that organization. As I mentioned, a few years ago, I was hired on at the Oregon Department of Geology and Mineral Industries as the public affairs coordinator. I wear quite a few different hats there. Of course, public affairs work, so working on messaging and looking at issues that the agency is working on, and devising communication strategies and that sort of thing. Media interaction, answering questions from reporters, arranging interviews, social media, which is one of my least favorite parts of my job. I prefer traditional media, but that is okay. I also schedule and actually perform outreach to communities for on various different subjects. I am the environmental justice liaison for the agency to the State Environmental Justice Commission. And just recently, we're actually working on some project funding where I would actually be doing social science research across the state related to clean energy transition work. So I'll talk a little bit more about that as well. So, wanted to talk a little bit about after, now that I've gone through kind of my experience, what did that reveal to me as with respect to community impacts and how that relates to geology? And I've got a few photos here. This first one is a excavation for testing soil next to an underground storage tank. This is a lovely old corroded drum that was found in a part of a client's property where nobody had been and was apparently illegally dumped there. Unfortunately, we never really figured out what was in there because it had been there so long that the testing didn't show anything. And then this last one is a pipes coming out of the ground from a heating oil tank in a residential property. From a diesel tank outside of the home, and these pipes coming out of the floor actually fed into the actual furnace for that heating system. And all of these are issues that I worked on as an environmental geologist, and that really demonstrate how this contamination can get out into the community and can cause impacts. So we have things like environmental exposure, health impacts related to those environmental exposures, neighborhood devaluation, and that's kind of in a big picture sense, economic depression, and then individual property devaluation. So there are really a lot of different ways that these problems can impact communities. Since coming on at Dogami, I've also realized the extent to which, particularly here in the Northwest, geology impacts the community through natural hazards. So at Dogami, we work on issues related to earthquakes, volcanoes, flooding, earth movement, so landslides and debris flows, wildfire, and that's, you might not necessarily think that is a geoscience related topic, but in fact, some of the research that we are conducting currently at the agency has to do with the impact on the occurrence of landslides and debris flows after wildfires have gone through an area. And then kind of looking forward at climate change mitigation and resilience strategies. So there are a lot of different ways that community factors play into how we approach natural hazard risk mitigation. Wanted to talk a little bit about, and I'm sorry, I did want to point out this picture is actually of the Eagle Creek fire. I personally took this picture. We were on the way back in from a camping trip and essentially got trapped on Highway 14 as we were coming into Portland, and this was the view, and we watched the fire unfold, and it was amazing and horrifying at the same time. Did want to just mention climate change and how communities are impacted by geological processes related to climate change. Again, you've got changes in weather patterns, so potential flooding, changes in flooding patterns, fires, increase in fires with the related impacts to earth movement, debris flows, and landslides. Coastal impacts, of course, sea level rise, coastal erosion, planning for tsunamis and earthquakes, and again, storms and landslides. And then going so far as planning of environmental remediation efforts. So the photo you see on the right-hand side is a picture of Willamette Cove. This is an area that is in just north of downtown Portland, and is part of the Superfund cleanup process. On this particular property, the Department of Environmental Quality, their original recommendations for the cleanup were to take all of the heavy metal and PCB contaminated soil, move it to one area of the property, and bury it under clean soil. Now, that's a proven remediation technique for reducing potential exposure to contaminants. But one of the questions that community members had was, if we're going to do this, and what you can't see in this picture is that there are homes very close to this area. What one of the questions community members had was, well, we know that climate change is changing weather patterns and potential for flooding. Does that remedial recommendation consider what will happen to that property in the wake of climate change, and how will that impact that cap that we call it? So, even in down so far as individual remediation of individual properties, we can see potential impact to the community from climate change. And then I mentioned previously, as we're looking forward to mitigating the potential for increased warming, but also increasing resilience of communities, there are a number of different ways that the clean energy transition also impacts communities. So we're talking about things like carbon sequestration, which is taking carbon dioxide out of the air and storing that underground. Energy systems resilient, so the siting of energy facilities. If you can see the photo on the right, that is the CEI hub in Portland. Extraction of lithium and other critical minerals, which will be something that is going to be something we're talking about considerably more in the future, and as we move forward with looking at cleaner sources of energy. And then geothermal energy and hydrogen fuel extraction. So all of these initiatives, all of these ideas have the potential to have some pretty significant impacts to communities, and a lot of them are related to the geoscience behind that. So very early on, I began to see how the impacts of environmental contamination fall disproportionately on different communities, be those communities of color, low-income communities, populations experiencing houselessness, or rural communities. I can tell a couple of different stories about this, but for example, one of my early remediation properties of a gas station in Beaverton involved a leaking underground storage tank full of diesel that leaked a number of thousands of gallons of diesel fuel directly into the subsurface. That diesel fuel came in contact with the shallow water table and was actually taken off site, and a plume went underneath a neighborhood adjacent to that gas station. That has implications for the folks living there, including things like vapor intrusion, where volatile organic compounds could actually come up through cracks in foundations or through basements. But it became really, really clear as I was executing that cleanup project, the client I was working with, it was a large oil and gas company. They had a lot of folks like me, environmental consultants and lawyers and engineers on their side to advocate for themselves. The state of Oregon, of course, has professionals looking at the regulatory side of things, but really the communities around this site did not have any recourse. They barely had any way of even knowing that these issues were impacting their property. And of course, their health impacts, but also, folks began then looking at devaluation of their property. How much has my property been devalued by this contamination that didn't even come from my activities there? So that's just one example. That I observed many, many more in my in both my professional experience and in my education as well. There are also issues related to brownfields, which are contaminated sites that are essentially just sitting fallow, some of those in neighborhoods, devaluing properties and potentially exposing folks to contamination. And then there's finally the issue of cumulative exposure. So what we know is that very often, and this again, disproportionately the burden falls on generally on communities of color and low income communities. But we know that some of these communities are exposed to contamination from all over the place. Now, when you're doing a standard remedial investigation, you will look at exposure based on one property. However, folks in certain neighborhoods in town can be exposed to contamination and other hazards from all over the place. So, for example, folks in the north portion of St. John's are close to the Superfund site, but they're also close to any number of industrial facilities. And by and large, up until relatively recently, those cumulative exposures weren't really evaluated. We're still in the process as a profession of trying to figure out the best way to evaluate those cumulative exposures. And once again, those generally tend to fall on those communities that are also disproportionately impacted by other factors as well. So what have I learned in all of this? First one is meeting communities where they are. This is a little social work buzzwordy. But what this really means is, when you're working with communities or working on projects that will be taking place in communities, it's really imperative that you understand the communities in which you're doing that work. So are there language barriers that may be associated with that community? Is that community Does that community have power to impact decisions that might affect them? For example, if a community is primarily non-English speakers, generally those communities will have less power because they have less ability to communicate with the regulatory agencies and the other power structures around. And then intersectionality. So understanding that these communities may be burdened by multiple different things, not just related to environmental contamination or geologic factors. One of the most important things that I've learned is that community engagement is really important, and it needs to happen early in the process and often. I will tell an anecdote from a recent talk I attended where someone was explaining a power storage project that they were working on. So taking renewable energy, which was producing too much energy at one time of day, and looking for ways to store that. Well, they devised this really ingenious way of using gravity and pumping water up to the top of a tower when there was excess electricity, and then at the end of that period, letting the water flow back and then recapturing some of that electricity. Well, they received significant pushback from native communities around the area where they were planning on doing this project. And I just asked the question, well, at what point in this project did you engage the communities? And the answer was all the way at the end. So, that is, I mean, having done the work that I've done and really dug into this, it's not surprising to me that if you don't tell someone that something is happening until the very end, you're going to get pushback on that. There's also the need for truthfulness and transparency in the process that you're using to plan and execute projects. And then finally, and this is one of them that is incredibly problematic for state agencies and other entities looking to do work, is that communities deserve the right of refusal. And it is incredibly challenging, but ultimately communities have to feel that their viewpoints are taken into consideration, and they really have to be given that power to refuse whatever project is happening. And again, that is one of the most challenging things to work into a project, but frankly, something that I see as essential. So I guess just to summarize, geology has a number of important and inescapable effects on communities. As we move forward, geology will play an increasingly large role in the transition to cleaner energy, again, carbon sequestration, critical mineral exploration and production. And as the climate changes, geology is also going to be critical to work on resiliency for communities and infrastructure in the wake of changing climate conditions. And then finally, environmental justice considerations must play a role in ongoing geological research and planning for all of this. So thank you for your time. That is my presentation, and yeah, I can answer any questions.
Well, thank you very much, Alex. That was really informative because that was a side of thinking about geology that through my work experience, I'd been involved with. One of the things I was wondering about is you didn't mention water wells. And I know here in Central Oregon, geology and water are pretty well tied together. And I'm assuming that was also, that would be another aspect of that linkage between geology and our communities.
Absolutely. There are probably quite a number of things that I did not mention in here because it's such a broad topic. I also have to say at this point that this presentation is not associated with the Oregon Department of Geology and Mineral Industries. This is a presentation I'm giving kind of independently of my role there. But you're absolutely correct. And as you've potentially seen in news articles recently, there are a number of groundwater issues going on around the state, but particularly in Central Oregon. And some of that is related to the permitting work that Dogami does for aggregate mining there. Again, all of this holds true with the situation with water in the state. Yeah, I think that's about what I will say will say on that topic. It is an active topic of conversation, and certainly as a regulatory agency for mineral exploration and development, that's something that Dogami is involved in. But we also work with our other state of Oregon agency partners like Water Resources Department, Department of Health, Department of Environmental Quality to try to address issues as they come up. Again, the state enterprise is large. It's a big ship to try to steer, particularly when you're trying to work with multiple agencies. So that is a challenge, but yeah, I will leave it at that.
All right.
Hopefully that answered your question a little bit.
It did. So Alyssa brought it up in chat, and I'll bring it up here. If anybody has any questions for Alex or for Melissa, and I see we might have, okay.
There was one that came in earlier that I'd like to kind of play with, if that's cool. So Edith had asked about the what people can do at like town meetings and things like that or town hall meetings to bring up issues from the public to elected representatives. And kind of the spinoff I wanted to ask about that is just kind of like, how can people get involved in ways that'll actually affect legislation?
Yeah, those are good questions. I mean, the first thing that I will start off with, and this is I briefly mentioned this in my presentation, but one of the reasons that I got involved with the Portland Harbor Community Coalition and environmental nonprofits in general was because in attending meetings and attending watching speakers, I found that there was often a disconnect in the way that state agencies and regulatory authorities speak and the way that communities speak. So, what I saw was kind of I guess a lack of ability of agencies and community to understand each other. Agencies will come to a meeting and talk about exposure limits and shallow groundwater impacts and things in relatively technical terms. And community members will push back and say, I've had health problems for 15 years, and I'm convinced this is related to X, Y, and Z. And oftentimes I would see those two groups talking past each other and not really understanding. So what I was initially attempting to do in my advocacy work was to create that bridge there. And I think I think I achieved some success there. For example, Cathedral Park in North Portland, beautiful, iconic park in the area. In doing some of our advocacy work there, we actually discovered that there was a polychlorinated biphenyl contamination actually on the park property that was not being addressed. And I worked with the community groups to actually write a very strongly worded letter to the Department of Environmental Quality to actually get that back on the radar and get that the cleanup kickstarted again. Now that was important because with my experience, I was able to pull all of the data off of the DEQ's own website in order to give it back to them and demonstrate this is why you actually have to do this. And not that community members would not have gotten there, but it was my hope to be able to offer my expertise in a way that would help connect those dots. So that was part one of your part one of your question. As far as part two, I'm going to tie it back into part one. So in thinking about how to approach environmental issues or other issues related to natural hazards or geologic hazards for communities, as I mentioned, it's important to kind of understand where, for community members to understand where agencies are coming from. I know it's frustrating working with state agencies a lot of times, and I know it is really challenging, particularly when you've got multiple agencies working on the same project. I do try. I saw a question about pushback in the chat, and I'll tie that in as well. That's one of the things I am consistently bringing up with management at Dogami is trying to establish really trying to establish communications and baseline with the communities so that everybody is speaking the same language. That is, it's challenging. I will say that it's challenging at the state to push those kinds of ideas because many times state agencies aren't used to working that way. As an example, um, you know, it's incredibly difficult if you're a community member advocating for an environmental cleanup to have an agency come to a meeting and then say, "Oh, that's not our job. You're going to have to talk to Department of Environmental Quality." And I am still beating the drum to have a more unified response. I mean, we have to recognize that different agencies do different things, but from a community perspective, folks are concerned about their health. They're not concerned about jurisdictional lines, and they're not concerned about agency purview. So, finding a way within the state enterprise system to talk to communities that really kind of broadens the way that the state works with communities. I feel like I might have gotten a little bit off topic, but hopefully that answered the questions.
Alex, Alex, I'm going to try to ask a question about politics, acknowledging first that GSOC is a non-political organization. We're nonpartisan. We have Republicans and Democrats in the room. But those of us like you and I who've worked within liberal or left organizations like NAACP and so forth tend to think of communities in terms of racial categories, whereas maybe if you're in Eastern Oregon, you're thinking more about communities in terms of rural interests and so forth. And when you talk about right of refusal, that's that. I assume you're talking about sort of countervening policy or statutory initiatives from your agency. How do you define the community? And I find it really exciting to see the breadth of your work. And then when you're, as I found when I was with the court system, you have an obligation to all members of the community, regardless of their partisanship or their race, class, position in society. How do you actually connect with those communities, and what defines the community?
That's a good question. I think I will go back to kind of that social work paradigm. The first step in that process is to understand the community that you're talking to. One of the things I try to push very hard at the agency is that although me and the state geologist and a number of other folks are located in the Portland office, it is really important for us to actually be there in person in Central Oregon, in Eastern Oregon, in Southwest Oregon, to demonstrate that, not only do we do this work from the Portland office for the whole state, but that we are actually a statewide agency that is willing to be in those places. That's it's just a it feels basic to me, but at the same time, I think I see agencies not doing that. And so, for example, we had a recent uh, interview with the media, and we actually had our director go out to Prineville to actually do that interview there. I think that's first and foremost, that is really part of that process of understanding the community that you're working with is showing up and just being there. A lot of times, meetings can be uncomfortable. A lot of times communities are bringing up things that folks don't necessarily want to talk about, but it is vitally important that agencies actually show up and do that work. Back to your question about how do you define those communities? Well, again, part of this process is understanding who those communities are. And at the beginning, one of the first things you do is a broad exploration of who are all the stakeholders within this community. So you're able to kind of put some definition around that. Earlier, when I mentioned the work on the Portland Harbor cleanup project, I mentioned that it's located in North Portland, but as work on that has gone on over the years, it's become apparent that that's not just a local resource. That's actually more of a regional resource, and particularly indigenous folks and Native American folks see that as, yes, it's far away, but it's still a cultural resource for the region, really. So that stakeholder analysis and really understanding the community is how you do that defining of who your community is. I do want to add that, and I think I mentioned it at one place in the presentation, but from my perspective, environmental, and I believe this is recognized by the Environmental Justice Council as well, rural communities are included in that definition of environmental justice communities, because often rural communities are overlooked, are frankly talked down to, and not incorporated in the conversations on development of policies and development of projects and initiatives.
Thank you, everybody, for joining us today, and we will have a similar event next month, so please pay attention to your email notifications and keep up with GSOC, and we'd love to see you next month.